I'm going to start streaming this up. Go ahead and load up. Where we left off the other day was with getting ready to install Ubuntu. It seems like forever ago that we were actually started this at this point. So there's my Ubuntu clean, and I want to start it up and let it install. So hopefully I'm going to say start, and I'm going to let it install, and I'm going to talk about virtualization a little bit as that sets up. Oh no, mine is somewhat freezing here. That's not a good thing. I don't know. What's it say? Yeah, click OK. Mine didn't start for some reason. So you can go ahead and start walking through that Ubuntu install if mine ever officially boots up here. Thank you. All right, let me try this again. Oh, for crying out loud. What's going on here? Oh, that one's running. I'm just going to trash this one. That one's starting just fine. And I'm just going to make a new one real quick. It's going to take me just a minute to get up to speed to where you all are. I'm going to go over that again in just a minute. Oh, I didn't click on power on, did I? Damn it. There it goes. There goes my Ubuntu. All right, so I want to talk about a few things here today as we wait on these virtualized environments to kind of install, and then we'll talk about other stuff. So we have a physical machine that we're going to refer to as our host from here out. You need to be aware of everything we're talking about, because this is how our domain runs, period. Everything from our servers to our switches are going to be running like this. Our physical machine has physical CPUs, and I'll put that plural, physical RAM, physical hard disk drives, or solid state drives. Somebody explain the difference between a hard disk drive and a solid state drive in less than 30 seconds.
Well, no, hard disk drive uses like magnetic disks to essentially write data, and an SSD uses like a flash, like a NAND technology to essentially store data.
So a hard disk drive is what we refer to as a mechanical drive. It has spinning hard disks on the inside of it, what we refer to as platters, with read-write heads that come out over the platters, and that makes it very slow. A solid-state drive, everybody knows what these are, flash drives, right? So think of it as a flash drive on steroids. Pretty much what they'll do is they'll put like 10 or 20 of these in place, right? Exact same NAND RAM that's in the solid states. The difference is they have a special controller that enables you to write to all these flash drives and read from all these flash drives at the same time, right? So there's this synchronous reading and writing, so it makes it very, very fast. In addition, we have access to our GPUs. What's a GPU? Learn something new every day, right? When you go to bed at night and you say, what I learned today? The answer is a lot, right? So a GPU is a graphics processing unit. A GPU is a general purpose graphics processing unit. General purpose graphics processing unit. Now, why do we need to know this? Well, when you think of artificial intelligence, or you think of big data, or you think of image/video processing, right? And even, driving a car, right? This is massive sets of data that can easily be parallelized, all right? So instead of one CPU working on one problem, what if we had 2,000 mini CPUs that could break the problem up and work on it, all right? So you find GPUs in AI work and big data work and image and video processing, all right? When you think about a car driving down the road, there's a lot of data that's coming in. They use these GPUs. It's the same graphics processor unit for your fancy gaming systems and laptops. It's just we're using it explicitly for these things.
There's processors on there. Is that what they do by like CUDA cores?
Yes. Yep. When you see CUDA core, it's the streaming processor. Yep. So that's all the physical stuff that makes up our host machine. And you need to scale to how big these things can be. The computer's in front of you. There's one CPU, all right? So you're going to see, I want to throw out something else. P stands for processor, C stands for core. So if you see a system that's an 8P 16C system, that means that physical machine, and it's really no different, it's just larger than what you have in front of you, it can handle 6 processors, physical processors, with up to 16 cores in each processor. So 8P 16C, that's what that means. All right, that's huge. So this is enterprise. All right, in front of you, same concept, except for it's a 1P, right? There's only one processor on the inside of these machines. And 4C, 4 cores. There's only 4 cores on these machines, right? So you know all of this, kind of, but just remember at the enterprise level, there's no such thing as making it too big or overdoing it. We're always going to use up these resources. In our RAM, in your computers in front of you, these have 32 gigs of RAM, but your home computer or your laptop probably only has 8 or 16 gigs of RAM. In the enterprise level, we can go 512 gigabytes RAM or more, right? Solid state drives and hard drives, these would kind of like secondary, and they go into the terabytes. And these would be primary, and they can go into the upper gigabytes, approaching terabytes, multiple terabytes as well. All right? So we have the same thing going on in the computer in front of you, but at the enterprise level is what I'm talking about here. So why do we have so much resources? Well, inside of our physical machine, inside of our host, we're going to start spawning guests. All right? Our guests are different flavors of operating systems. So maybe this is Linux. Maybe this is Windows 7. Could I have a Windows XP up there? What do you think? Should I have a Windows XP up there? In a perfect world, we wouldn't have Windows XP up there. Why? It's old. They don't support it at all. They don't care how much you pay them. They're not going to support it. But why might we, as network administrators, have to have an instance of Windows XP running?
Well, I mean, like, certain software that we use in the hospital will run.
There you go. And nobody wants to spend $50,000 on that piece of software because it only does this one little thing, right? So what do we do as network administrators? We need to be aware that it is there and it's on our virtualized environment, and we need to set up our network in a way that we can mitigate every possible threat that we can think of, right? So on the machines in front of you, you can spin up about 10 guests on the inside of it without a lot of load. You won't have any problems. On one machine of this capacity, you could easily spin up about 40 to 50 of these machines without any problem. All right? Now I'm going to take it to the next level to give you this idea of virtualization and how cool it is. Most of the big hosting sites, you want to make your own website, what is their guaranteed uptime? Anybody ever gone out to try and host your own website? No, guaranteed uptime. They promise you that when you go there, it'll be there. And they have a guaranteed uptime. And it's measured in percentage of the year. Anybody want to know what a lot of them do? A lot of them will give you a guaranteed uptime of 99.999% uptime. All right? When you break that down over a yearly basis, that means that they'll be down 15 minutes out of the whole year. Those nines make a difference. Put another 9 on, it's like a minute, right? 2 minutes. Another 9 beyond that, it's like seconds, right? So now as information technologists, aspiring network administrators, how do we do that? How do we accomplish this promise that we made our customers that we will be available to them 99.999% of the time when we have these physical machines called hosts which need servicing? Fans go bad, RAM goes bad, CPUs go bad, hard drives need replaced. You following me? Virtualization is your answer. So you get not one host, not 2 hosts, not 3, not 4, but 5 in this particular example. This represents what Frostburg State University has running on Lowndes in our data center. We have 5 physical hosts running. Okay? This is very high-level view. I get if you can't wrap your head around all of it, but it'll start falling in place as the semester goes. So ask questions now, and if it gets too in-depth, they'll just say, well, let's wait. We'll figure that out as time goes. All right? Well, this is what it looks like. And inside of each of these machines is all of that except for the hard drives. All right? So the hard drives are over in another storage area network device, a SAN, storage area network. Now, if you know what a NAS device is, that's a network attached storage device, right? It's similar except for this is a network, all right? And inside of this storage area network device are about 50 hard drives and like a dozen solid state drives. All working together, we have about 100 terabytes of storage space in that.
What did you say SAN represents?
Storage area network. And it's a special type of network that is all about just storing. That's it. Storage area network. Now, all of these devices connect via fiber over to my SAN. So that means none of these actually have hard drives on the inside of them. So imagine your computer's in front of you or your laptop, no storage device on the inside. It's all in a closet in the back of your house. That's kind of what's going on here. There's no storage on the inside of these devices. It's nothing but CPUs, GPGPUs. I don't think we have any GPGPUs up there because we don't do anything with that. RAM, power supply, so on and so forth. That's what's in here. And we have 5 of these. And we run about 180 guests across all of these devices. So when you go to www.frostburg.edu, it's coming off of that device, with all of the content actually being stored over in this SAN device, right? When you go to your email anymore, your email is actually authenticated through this. Your login is, but the email itself is remote. Chemistry has a couple of servers on here. We don't have any servers on here. All of the pause stuff that you do, it's on and processed through this and stored in this. Now this is a big RAID array, by the way. We'll get to that later. It's a big, huge RAID array. RAID stands for Redundant Array of Independent Drives. Redundant is key here, because we certainly don't want to lose anybody's information. And we have redundancy to our redundancy to our redundancy. No kidding. We have a duplicate setup in Hagerstown, exactly like this in Hagerstown. And we back everything up to tape. And these are things that you as a network administrator have to come to grapple with, right? Think about this scenario. We have a fire. We don't have backup. Shay comes to me 10 years down the road, says, I need proof that I graduated from Frostburg. Sorry, dude. It'll all burn up. How pissed are you going to be? Pretty pissed. We have no official way to show that you ever went to Frostburg if we don't have backups on our backups on our backups.
What happens in situations like that? Because I remember you telling me that there was like a high school caught on fire and like
Yeah.
all the kids.
Yeah.
What happens? Like what is
They guessed.
afterwards?
They guessed.
Like so when they're applying to colleges, they just can say that they graduated with a 4.0?
I don't know what they did in that situation, but yeah, you're literally that screwed if your information is that sensitive. And that's why when I tell you this one setup is about $200,000, so we duplicate that, that's $400,000, and then we have backups on the backups, right? And that's a little bit cheaper. That's like $50,000 or something like that. Now you can understand why, right? Question? RAID, redundant array of individual drives, of independent drives, right? That's redundancy layer 1. Duplication of this is another layer, right? And then backing up is yet another layer, and they're geographically separated. And now we're talking about hot and cold sites. So this is a really big overview of things. If you're like, you should make my head spin, don't worry about it. It'll all come together, right? This is all about virtualization, helping you understand the importance of everything. So here's the deal. Each one of these has a dynamic link and a virtual link over to the RAID array on my SAN, right? This particular host says, I have a fan going bad. Please replace me. I'm making this very simplistic because most fans you just pop out and pop in a new one while the machine's running. Let's say that it's indicated that one of the processors has gone bad, right? Let's do that. That's a little better example. Using VMware, you send a message to that machine. All right? And you say, I need you to come down. I need you to shut down. This is how it maintains 99.999%. All right? This machine, remember there's 180 guests being managed by all of these, right? This machine says VM1, here let's label these, 1, 2, 3, 4, 5. And each one will say is at 20% of its capacity. Can you imagine that? So you know you have your task manager running, and it shows how much resources is being used on your computer. Do you know what I'm talking about? This thing, can I show it to you? I don't know if I can or not. This thing right here, right? So it's idling at 20%. So each one of these is idling at 20%. This one says, I got an emergency. And it has, a portion of these guests running on it. Well, the system says, no problem. It breaks the virtual link with this machine, reassigns it to this machine. Now remember, all your data is over here, right? So it just, instead of pointing here, now it just points here. And it says, you take over this guest. And you take over this guest, and you take over this guest. And then what happens is, this goes to 0 because it's shut down, and everybody else goes to 25, right? We'll say that it magically redistributes perfect. It probably doesn't really do that, but we'll say that it does, right? So now, everything's still running, completely transparent to all of the users. This is the beauty of virtualization, right? Everything's still running. Everything's perfectly fine. We pull out the machine. We fix what we got to fix. We push it back in. We turn it on. vSphere texts us and says, I noticed you turned that machine back on. Can I migrate everything back over to VMware 3? Why, yes. Thanks for asking. Punch of a button. Everything goes from 25%. This comes back up to 20. And now they're all evenly distributed back at 20%. Now, if that's not mind-blowing enough for you to think that those 5 physical machines can magically manage all of that by themselves, I'll blow your mind with this. The largest data centers are 1 million square foot. Probably about 100,000 square feet are filled with machines like this. And the rest of it's filled with hard drives and cooling and stuff like that. All right? So when you think Amazon AWS, right? Amazon Web Services, AWS. Amazon, that's where Amazon makes their money. Those of you that had me before know this. That's where they make their money, is in cloud services. You've been on Amazon's today. If you've watched Netflix, if you've been to websites, 150 of the largest websites on the planet are housed in Amazon's cloud. So now, what I want you to start thinking is when you hear the word cloud, you want to start saying, oh, they mean virtualization. That's what it is. I mean, really, to most people, does cloud sound cooler or virtualization? Put it in the cloud. It just doesn't ring as well if you say, put it in the virtualization. Right? So that's what is going on here. There's nothing really magical about it. It's just, we as human beings, we can't physically manage 1 million square feet of racks. So we need the software to be able to help us out and write the different scripts. Typically, anytime that Amazon has gone down, do you know whose fault it was? It was always a person's fault. A human misclicked. Isn't that crazy? Here, let me take a picture of this for the video, in case you want it. Big old mess up there. Maybe I should have recorded it at the same time. Okay. So that's a really big enterprise look at what we're talking about. So now we're going to come back to our virtualization in front of us. And I need you, for the rest of the semester, to keep this in mind. Everything we're talking about, you can do in your own machine. You have experience with it. You've touched it already. So what's the difference between what we're doing in the enterprise? Money and scale. That's it. All the problems are still pretty much the same. They're just bigger at the enterprise level because we have to deal with 5,000 users, or if you're Facebook, 2.2 billion users, or whatever ridiculous amounts of people they have on their platform. Right? All right. Any more questions about this right now? Pretty good? All right. So back to this. Let me show you some more really cool, powerful things about what's going on here. So you want to take notes on this. I want to show it to you. You want to take notes. So this is Ubuntu. It gives us a nice safe place, this virtualization, a nice safe place to be able to experiment and play. As I said the other day, in our case, with networking, well, you can play with viruses. Maybe you want to test how a product is going to play in your environment as a network administrator. Well, what better place to put it than in a VMware and test it out before you implement it in your overall network, right? You got a new domain server that you want to test out, you put it in there. You got a new firewall, you put it in, you experiment with it, so on and so forth. But there's some other really cool, powerful things that we can do here. I am going to right now show you a new tool. I want to right click and I want to say snapshots and I want to say take snapshot. I want to name it before playing and I want to say take snapshot. So it's just a simple right click, snapshot. You logged out, didn't you? Look at that. You got so into my lecture, you logged out. If he keeps it up, Shay, just trash the whole thing and restart it. And just redo it. It's good practice anyway. See this, hit stop and then go from there. Yeah, you can just trash the whole thing and just remove the whole thing and reinstall it. Yep, take snapshot. Take snapshot. There you go. That's the beauty, again, with this. You can't do anything wrong on these guys. You know, you just can't. Don't worry about it. You trash them. You start them up again. It's just a lot quicker than, now where did I go wrong with that? All right? And that's where snapshots kind of come into play. So I'm experimenting, and I accidentally go down a dark path. So I'm going to kind of come through here, and I'm going to watch all of this. I'm going to go through this. I'm going to hit done. And then, I don't know, maybe I want to put something out on my desktop, or I want to change my background. Let's do that. I'll change my background, change it to something else over here. I want to change it to that. That looks cool. Or that. If I can get to that. Come on over here. It's giving me a fit. Select. There we go. Now, I've gone down this path, and I've decided that, no, that's wrong. How come I didn't change my background? Come on. Let's see here. Oh, that's because I did just my lock screen. Hold on. There we go. So I changed it. But imagine that you're installing DHCP or something like that, or you're following instructions in the lab manual, and you took that snapshot. All right? This is an important tool. You took that snapshot, and you got yourself stuck. And you don't know how to unstuck yourself. If you took the snapshot, you can just roll back to that previous state. So I come back to my snapshot manager. I right-click. I say snapshot, snapshot manager, and I say I want to go back to here. Please go back. Are you sure you want to do that? Yes. And not instantly, but pretty darn close to it. Hold on. Well, let me click exit on that. Pretty darn close to instantly. I'm back to exactly where I was when I took that snapshot.
How do you do that again?
Use the snapshot manager. Right click on whichever guest, go to snapshot, and you can just take a snapshot. By the way, you can take multiple snapshots along the way. Right? So that's one really powerful thing that we're capable of doing. Here's another very powerful thing. Be sure to take notes. I want to shut this down at this point. By the way, I do not have the guest additions installed in here, and I should. You would say reinstall. Oh, maybe they are installed, and I just got to do a reboot. But I want to come in and I want to shut this. I want to shut this instance down. I need to do it for what I'm going to perform next. Let's say that I need not one instance of Ubuntu, but I need two for whatever reason. And I have it set up exactly the way that I need it to be. I can make a clone of my machine. So I come in and I right click and I'm going to come down to manage and I'm going to come over to clone. And then it's going to ask me some different things. I want to clone the current state of the virtual machine. I want to do a linked clone or a full clone. So let me explain this. So this volume represents my guest. Right? That's what that represents. If I do a linked clone, a new volume is created that's much, much smaller. And it's based on the underlying original. So what happens is, every time you do something and change it, that's stored in this volume, but it's always based on that original volume. So that's a linked clone. You understand? Takes up a lot less space on your hard drive. Now, it's pretty easy to deduce what is a full clone. A full clone is going to be the exact replica same amount of space, and now completely independent from one another. Linked clone, not independent. They're dependent on one another. So if you were to delete the original clone and a linked clone, I'm sorry, the original and a linked clone, that won't run anymore. Over here, it's a full clone, independent of the original. So I'm just going to say create a linked clone just so you can see it. It'll say clone of Ubuntu 64, done. It only takes a second. And now I have both of those. I can power on both of those. Hopefully they'll still boot up because I don't know what I did. I did something on a setup there. So there they go, completely booting up each one of them. Notice the tabs, so if you want, you can pull these guys out. I also got this Windows 7 over here. Probably need to shut that guy down.
What did you say the purpose of creating a clone was again?
Well, you have two options when you create a clone. You have a linked clone right? You have the ability to do a linked clone, or you have the ability to do a full clone.
I'm saying, why would you?
Well, you tell me, when would I need to clone something that I'm working on? What if you have a production environment that has a glitch? Something weird's going on, right? Set up as a guest. I'm not going to go into that production environment on the fly and start messing with stuff. Because why? I might mess it up worse than it already is. So I make a clone of it. I start playing around, figure out what the solution is. I test the solution. I go back to the original. I implement my fix, and I delete the clone. Yeah.
Okay, so if I can't make a clone of my virtual machine or snapshot that is powered on or suspended, so what is that?
So you have to either power it down, or if it's in suspended mode, meaning it's paused, you have to unpause it, and then you can do that. So in your all's cases, for the clones, you're going to have to make like 2 workstations. You're going to have to make 2 servers. It's pretty nice just to say right-click, make a clone.
What was, like, when you initially started, what would you say about the linked cloning? Like, I understand, like, Ubuntu clone, it's just a complete...
That's all by itself, right? In a linked clone, this volume represents a differential between what the original was and what you've been doing on it.
Okay.
That's all that's in that particular volume. It's much smaller.
Okay.
Also, if the original goes bye-bye, you can no longer access the clone.
Okay.
Right? Over here, it's completely independent.
Are both of these really, typically...
They're both useful.
One or the other when it comes
No,
to
they're
the-
both useful.
Yeah.
In a testing scenario, I'd probably make a full clone,
Yeah.
right? If I just need something temporarily for a few minutes, maybe I'll just do a linked clone. Because it does take longer to generate the full clone, right? Because it has to rewrite all that data. And when I say longer, 30 seconds versus 2 seconds, you know, kind of thing. But in a very large, let's say it's a 100 gigabyte one, that might take an hour to generate a full one, and it might only take 30 seconds or less to create the linked. Okay. So that's a very useful tool as well. And what questions do you have that I need to clear up? I'm hoping you're going to continue to play with this stuff. You play with the snapshots. You play with the cloning, right? And the reason we do that is so when we start these labs, you can start using those tools, because this is how we're going to do all the labs is in the virtual environment. That's why I'm taking such an enormous amount of time. This is supposed to be my Friday lecture, right? So we're supposed to start doing more stuff. But you need to start playing with this stuff so that you get comfortable with the virtualized environment. Start up like 5 different servers at the same time, right? And see how you can keep track of them. I would recommend paying attention to what you name them. And then I'll show you some other tools that will help you keep track of different things as well. All right? But right now it's about organization and how we're going to be leveraging this virtualization technology. And then I went through everything earlier so you understand just how powerful this is. On your resume that I know all of you have going, you should have virtualization on there using VMware Workstation. Right? Virtualization using VMware Workstation. I understand the point of cloning. I understand snapshots. And now you have a real-world example of why would I ever want to clone something. Right? You have a story behind it. All right, one last thing that I'll show you here, and then I'll let you go because I know I'm about out of time. In Canvas, this is really important for us to know. There's this VMware Help, and under VMware Help, I have bridged, internal network only, and NAT with DHCP. All right? Now, while I was looking at this, while the operating systems are out of date, the names of them, the premise is exactly the same. So when we set up a new network connection, so if I come in here and I say right-click and I go to Settings and I say Add, Oh, you son of a bitch. Can you guys do that? Did it say the same thing to you? You can't add another one? Another Nick? Ooh, that's a big issue. I'm glad I did that. Click cancel and let's see if we can do it anyways. Click on, I want to add another network adapter. Click next. So here's the bridged, NAT, and host only. So that's what you're looking at. So this is bridged. So bridged means that my guest, so these are all my guests. My guest is plugged into a bridged switch that goes out to the host. Oops. If you click on internal network only, host only, this is what it looks like. It doesn't go outside of the host machine. The host machine is the orange, right? It just plugs internally into a switch. And then custom, NAT is the other one. What happened? Oh, I see. That's because that popped up. Let's see. Is that better? Yeah. All right. Sorry about that. That's okay. So the bridge, these are just under the files. You go bridged, internal, so on and so forth, and it kind of explains it. So if we look at the bridged, the orange is the host machine, and then inside we have all these guests, including a guest bridge switch. Right? Again, things we want to play with. Then we can customize specific virtual networks, and we can come in and say we want it to be on one, or we can actually add in our own names, which we'll play with later. So experiment with all of this stuff. Play with it so you can see how it reacts, right? When I plug it in bridged, I get a different IP addresses when I plug it in. Host is when I plug it in when I get NAT. All right? I'll see you on Wednesday. We're going to continue. If you haven't been reading and doing that homework, read the labs too, so you get a feel for the labs, right? It's important. It's a lot of material. It's a big learning curve in the beginning.